Filling in this chart, we're going to remember a couple of things. One is the formula for an exponential function, which is y equals c a to the x. C is your initial value. A is your growth or decay factor, depending on the number. If it's bigger than 1, you're growing, and if it's less than 1, you're decaying. And then the other thing you want to sort of remember is the connection between the growth factor and the rate and the decay factor and the rate. Decay is going to be subtract the rate, and the growth is going to be adding the rate on. So the first thing we're going to do is look at this function here, and I see that the initial value is 25, and I can also tell that it's a decay problem because our number here is less than 1. So we're just going to write decay. The factor is what we're multiplying by, so that's the 0.05. That's my A value. This column is going to be representing our A, the factor. This column is going to be representing the R, the rate. So since this is a decay problem, I'm going to be using the decay formula here. All right, and then plugging in. So my A is 0.05. I'll do this up here. 0.05 equals 1 minus R. Subtract 1 from both sides, and you're going to get a negative R equals a negative 0.95. Or if you divide both sides by negative, it's just R equals 0.95. So that's the rate as a decimal. If you times it by 100%, that's going to change it to a percent, or move the decimal 2 places to the right. So our percent is going to be 95%. So again, you're just multiplying by 100% here to convert it back to a percent. All right. So for question number 2, they don't give me the equation, but they give me information about it. So they do give me the initial value, so I'm just going to call it y equals 300. Then I need the A to the x. Well, in this problem, the column A is the factor, so I'm going to put that in, 1.14. Remember, our factor is what we're multiplying by. Because this number is bigger than 1, this is a growth problem. And if I want to find the rate, I have to use the growth formula here. A equals 1 plus R. So RA is 1.14 equals 1 plus R. Subtract 1, and I get 0.14 equals R. So R equals 0.14, times it by 100% to get the percent, and we get 14%. Okay. All right, let's take a look at this one next. So the initial value is 1,005. So 1,005. And then figure out my A, which they tell me, 0.15. All right, because that's less than 1, this is decay. And then again, back to the decay formula, A equals 1 minus R. All right, well, this is A, so it's 0.15 equals 1 minus R. Subtract 1 from both sides, negative R equals negative 0.85. Divide by negative, R equals 0.85. You're just dividing by negative 1 to both sides. Notice our values here are all positive numbers. We're never putting in a negative number for A or our percent R. So our R came up 0.85, times it by 100% to change it to a percent, and that's going to be 85%. Right, let's skip down to the last one here, where they again give me the information in the equation. My initial value, 24. The 1.03 is bigger than 1, so this is a growth. That is the A value. So again, plug in the A, and we use the growth, which is the addition formula, to find R. So subtract 1 from both sides. 0.03 equals R. So we come back up here, R equals 0.03, times it by 100%, and we get 3%. The other ones don't give us the A, it gives us the R value, which is okay. We can still use our formula, but before we plug 85.6% in for R, it has to be a decimal. So again, to get rid of the percent, you would divide by 100. So if I divide by 100, the R is 0.856. If you divide by 100%, the percents cancel, and then take 85.6 divided by 100. And the same thing here. You know, divide by 100% to get rid of the percent and change it to a decimal, and it's going to become 1.28. That's your R value. All right, so now let's back it up. Going to this third one here, y equals 54. Got to find A to the x power. I know what R is, and I know it's a decay problem. So I've got to use the formula A equals 1 minus R. But I know what the R value is right here, 0.856. And I'm looking for A, so I just plug in the 0.856 for R. All right, and then go ahead and use your calculator if you're not big into decimals, because all you're doing is just subtracting these two here. So 1 minus 0.856, that gets us 0.144. Now A is not a percent. A is whatever it comes up, that's A. So in this case our A is 0.144, which makes sense because this number had to be a number less than 1 because it's a decay question. So in this next one here, my C value is 8. I'm looking for A. I know it's a growth, so that number is going to be bigger than 1. And I know what my R value is. So again, coming over here, if it's growth, I've got to use the 1 plus R. Growth is plus, decay is minus. Plug in your R. And we get A is 2.28. So that's my A. And it goes right in here.